Hello student, now we are starting next unit, WDM concept and components. In this unit, first we are going to get familiar with the evolution of technology, then what is a WDM concept, and afterwards how many components, active and passive, are required to study or which are used in wavelength division multiplexing. So I'm Bhagyashri Thorat and welcome to my channel Pinnacle. If you like this video, then don't forget to like and share this video with your friends. Also subscribe my channel for such informative and interesting video. Pinnacle Bhagyashri Thorat. First part is what is WDM concept. Before starting WDM concept, we have to understand how technology evaluate. In a first window or when the fiber optic communication is started, the source is a LED, then regenerator, multimode fiber is used and receiver. But in first generation, the number of regenerator required is more and proportionally the cost is also high. That's why fiber optics is not used frequently or fiber optics is not a preferable system for communication sector. In second window, multiple longitudinal mode laser is used. What is a multiple longitudinal mode laser? In that, your threshold value is higher for various modes. Because of this laser, the distance is increases for regenerator placing. And here is your receiver. For 1.55 micrometer window, single longitudinal mode laser is used. Because of that, only one mode is having a higher value than threshold. And because of this, the line width is precise and the distance for transmission is increases. Similarly, regenerators number is less and cost is less. So this is a evaluation of technology that single longitudinal mode lasers are used. Then we are using the multiplexing concept, many to one, then optical amplifier, demultiplexer and receiver. So this is need or evaluation of technology to increase bandwidth. Before starting to study the WDM, first we have to check why WDM. So WDM is used for four reasons: capacity upgrade, transparency, scalability and wavelength routing switching. So capacity upgrade means what? When we are installing the fiber optic cable, we have to dig and the installation is done. And every time when you want to upgrade the network, we can't install the fiber because it is a costless process. But by using WDM, you are just changing the input device, multiplexer and laser, and the capacity is upgraded. Then second and very important thing is the transparency. That means for every different channel, the different transmission formats is supported. That's why the different bit rates that is available, analog or digital signals can transmit. Then if in future when we want to upgrade your network or scalability. Scalability means how much you can easily expand your network. So by using just by buying and installing equipment, multiplexer, demultiplexer, source receiver, we can fulfill the additional demand as needed. Then wavelength is used as another dimension because now we are routing by wavelength. So in a fiber optic, wavelength routed switches, wavelength routed nodes are used, and that's why wavelength routing and switching, which is beneficial, we don't want to convert it in another format. This is the basic block diagram of wavelength division multiplexing, and always remember this is the individual fiber line. So this is lambda 1, lambda 2, lambda n optical multiplexer, and you are converting in a single line fiber lambda 1, lambda 2, lambda n. To understand the efficiency of WDM, there are two examples of sonnet. In first sonnet, we are going to use the TDM, time division multiplexing, and in second WDM. So for TDM, we know that particular time slot is given to one channel, and because of that, the bandwidth is N into B. But in a WDM, at the same time, we are transmitting all channels. So that's why bandwidth for every channel B, a capital B, bits per second. So that's why the bandwidth is not divided. Now, this is a basic block diagram of wavelength division multiplexing. Data in, then transmitter, then optical multiplexer, optical amplifier, point to point, this is a link, then optical demultiplexer and receiver. So to perform the wavelength division multiplexing, we want to combine, distribute, isolate and amplify optical power at different wavelengths. So that's why we require passive and active components also. Before starting to study the passive and active components, what are the types of WDM? So WDM types are CWDM and DWDM. In CWDM, is having a higher wider channel and spacing is 20 nm and it is having a low cost. And dense WDM, dense channel, the spacing is 0.8 nm and which allows simultaneous transmission of 16 plus wavelengths and it is having a higher capacity. So according to your choice, you can use DWDM or CWDM, but widely DWDM is used. So the first WDM network is use two wavelengths 1310 and 1550 nm. And in today's WDM systems, we can utilize 16, 32, 64, 128 or more wavelengths in the 1550 third window. The wavelength provider independent channel is can transmit 10 gigabits per second highest speed. Means minimum speed, we can increase that speed using different devices, precise devices. Now the standard grids that are available for spacing is a 50, 100, 200 and 1000 gigahertz. That wavelength spacing is particularly depend on laser line width, means how much the laser is having a precise line width, and optical filter bandwidth, because when you want to add or drop the wavelength, this optical filter bandwidth is very important to decide the efficiency of a system. Then what are the ITUT standards or transmission windows for WDM? So 1310 and 1550. In 1310, the available bandwidth is 14 tetrahertz and 1550 available bandwidth is 15 tetrahertz. So we are getting almost 30 tetrahertz for transmission and the spacing is 0.8 nm. So these are the principles of DWDM. Bandwidth of a modulated laser is 1050 megahertz 0.001 nm. Typical guard band 0.4 to 1.6 nm. 80 nm, 80 nm for 14 tetra or 14 terahertz at 1300 nm band, and 120 nm or 15 terahertz at 1550 nm. Then already we know that the discrete wavelengths, so individual channels that can modulate, routed and switch individually. And for this we require a variety of passive and active devices. So now we are having all the advantages of DWDM or wavelength division multiplexing. Now there are limitations for DWDM. There are only two limitations. First one, that we want physical realization of WDM network. So precise wavelength selective devices is the first requirement and this is a limitation. If your wavelength selective device is not precise, then WDM is not a success. And second is an optical amplifier, because if you want to work without repeaters, then optical amplifiers are required. In the next video, we are going to check WDM component. If you like this video, then don't forget to share with your friends. Thank you.
For more information of this topic, don't forget to subscribe my channel Pinnacle.